Okay, so this is part A of the test, or the test A, I should say. There's two tests for this chapter. Choose a letter and then three single-digit numbers. So we've got a letter and then three digits. So there are 26 different letters you can have. The first digit can be 10 different things, 0 through 9. And it seems like we can repeat. It doesn't say anything about no repeating. So you would just multiply that out in your calculator, 26,000. Suppose you find 7 equally useful articles related to the topic of your research paper. In how many ways can you choose 5? So I think order doesn't matter in this because I'm just picking 5 out of 7. It doesn't really matter which one I choose first. It's just not more valuable. So you're going to use NCR. And so there are 5 events or trials here, and you're going to choose, or sorry, it is 7, choose 5, right? Get this ready. So this would be NCR 7, 5. 21 different ways that could happen. You should rotate tires on a car on regular service intervals. And how many ways can 4 tires be arranged on a car? Okay, so we have 4 slots, 4 events. We're deciding the order. There are 4 ways the first spot could be chosen, then 3, and then 2, and then 1. So you're choosing as you go. 6 times 4 is 24. There's 24 different ways. Now, expressions, so you're definitely going to want to get a calculator out for this one. So you hit Control Divide, 12, whoops, 12 exclamation point is down here, and then over 4 exclamation point, and you get 199584000. So 19 million. Wow, pretty big. NCR, so you can type it in or just go to probability. That's a combination. It'd be 5, 2, which is 10. And then menu probability permutation, 7, 4. That'd be 840. See, I can't see marbles. Okay. I can see everything. Okay, so a jar contains 10 red, 30 blue, and 20 green. What's the probability of each? Probably red. So I'll do the denominator first. I've got a total of 60 marbles, and I want red, and that would be 10 out of 60, which is 1/6. And not red. So it's still choosing out of 60, but not red would be all the others. Well, 20 and 30, green and blue, add up to 50, so that'd be 5/6. Happy with blue or red. There's no overlap between the two, so I'm just adding those, so that'd be 40 over 60, which is 2/3, if you simplify that. See, toss a die. I want to get odd or greater than 2. So like one way of doing this is kind of like 1, 2, 3, 4, 5. Like those are the 5 outcomes, right? Odd would be like the 1, the 3, and the 5. Greater than 2 would be, so larger than 2, 3, 4, 5, and 6. So pretty much everyone has a mark by it, so except for 2. So I would say it's 5 out of 6. Because or includes, either one. It doesn't have to be both. Let's just write out the digits. It does help to know what a prime number is, by the way. Prime numbers, the first prime number is 2. So prime would be 2, 3, 4 is not prime. 5 is, 6 is not prime. Odd would be 1, 3, 5. And or means either one is true, so 1, 2, 3, 4 doesn't have one, and 5, 6 doesn't have one. So this would be 4 out of 6, or 2/3. Do have marks by them. and you don't replace the marble. So these are multiple events. You select a red marble and then a blue marble. So first you want to get red. Let's see, that would be 2 out of 6 times. Then you want to select blue, so that would be 4 out of 5. That's the kicker there. Once you choose the first one, you have one less marble. So you simplify that. That's 1/3. Okay, so that'd be 4 over 15. Both marbles are blue. So so that would be 4 out of 6 times 3 out of 5. Right, 4 out of 6 will cancel. 3 and 3 cancel. So I get 2 over 5. 2/5 chance, 40% chance. Use a table. What is the probability the recipient is male? So let's see. So male would be, I'm going to add these up. So all the males together would be 3, 4, and 8, 843. All the females, I'm going to go ahead and just add this up so I have them, would be at 1, that would be 9 and 1291. Add those two up. Let me just do that. I want to get the total number of people because I don't know what it is. So that's the grand total number of folks. Okay, so with probably this male, I've got 843 males divided by the total of 2134, and then I just type that in my calculator and good to go. That might simplify. Should I do it? So let's see. This is 843. Oops. And that's it, actually. Given that the degree is an associate, so there's an associate's degree, so all I care about are the total associates. That would be, if I add those together, 8, 7, 6, 678 of them total. If I add those up, if I add those. So that denominator is going to be 678. The numerator is, what's the probability is female? Well, 433 of those. So 433 divided by 678 is exactly that. Just leave it there. Set the 6 there. Given that you're female, so all I care about are the females. There are 1,291 females, so that's the denominator. And bachelor's degree would be, so of the females, 858 of those females have a bachelor's. But when we go to college, for sure more than guys. Okay, so this simplifies to be 143 over 113. Okay, let's just start making a tree diagram here. So you have 2 lacrosse coaches. There's 60% chance that Steve will coach and a 40% chance that Leslie will coach. With Coach Steve, the probability of being goaltender is 0.75. With Coach Leslie, it's 0.3. So make your first decision, which I think is which coach. So I think there are 2. One of them is Steve, and one of them is Leslie. The probability of Steve is 0.6. Probability of Leslie is 0.4. With Steve, the goaltender. So now goaltender, I'll put goal there, or no goaltender, no goal. So goaltender 0.75. So this would be 0.25. So if you want to be goaltender with her, that's going to be 0.3, and no goal would be 0.7 because that adds up to 1. So I like to figure out the ends here. I'm not sure what this question is going to ask, but usually this helps quite a bit. So you want to multiply 0.6 times 0.75. This one you want to multiply 0.6 times 0.25. This one would be 0.4 times 0.3. This would be 0.4 times 0.7. And these should all add up to 1 or 100% here. So I'm going to calculate out. 0.6 times 0.75. Oops. I'm stuck with the decimal point. 0.6 times 0.75. 0.6 times 0.25. 0.4 times 0.3. And 0.4 times 0.7. Okay, so 0.45, 45% of the time, 15% of the time, 12% of the time, and 28% of the time. If you add those up, it should add up to 100% or 1. Let's answer the questions now. We surely have enough. Given that you be goaltender, what is the probability that Leslie is the coach? So given that I'm goaltender, so that's the given, so that's my denominator. So what's my denominator? So that's going to be like, goaltender would be this and this, right? So if you add that up, that's 0.57. So in the denominator is 0.57. And the numerator is what's probably Leslie is the coach. So Leslie's coach for this one, so that'd be 0.12 over 0.57, or 12 divided by 57 if you want to do it the fast way. 12 divided by 57 is 4/19, which is the answer. So there's, if you wanted to do that as a decimal, there you just hit Control Enter, and you get 0.21, so 21% right there. Sorry. Get back to okay. That is the end of the first worksheet, but we're going to go on and move to the second one. So find the mean, median, and mode. So you could, if you wanted to, put this in the data or listen spreadsheet page. So I'm just going to call it data. 17, 21, 19, 10, 15, 19, 14, 0, 11, 16. So I'm going to do one variable stats on this. So I'm going to add a home calculator page and go statistics, stat calculations, one variable stats. So this is going to be data. And if you look at it, you get X bar, which is the mean, is 13.7. And the median, it says is 14.5. You could actually put that in order first and then find the middle number. You can also add them up to the calculator to divide by the number of terms, and that would work as well. I'm going to call this a data box because we're doing a box plot with it. And I'm going to type it in 7, 12, 3, 14, 17, 20. Let's just say it, sorry, 5, 3, 17, 13. Okay, tapped all in. Notice the last cell I went out of, which is good. Add a calculator page. Oh, let's make a biscuit one. Box and whiskers. So we're going to choose box. And you're going to menu plot type, plot. And that's just like having done box and whiskers. So you have to decide on, let's see, the biggest number, the smallest number looks to be 1. The biggest number is 20. So you need to make this at least 1 to 20 or 0 to 20. So 0, let's make this 5, 10, 15, 20. Probably could have done that differently, spread it out a little more, but I'm okay with this. Okay, so the minimum value is 1. Q1 is 4.5. Median is 10.5. Q3 is 15.5. And the max is 20. Or something like that. That's pretty good. As long as your your scale needs to be nicely ordered. and you plot the points correctly. It's not a bad idea to write what they are. I stopped doing that, but I probably should have written 10.5 and 15.5, etc. Find the mean, variance, and standard deviation of the data. So again, I'm going to have to type this in. So let's go to the spreadsheet. Let's call it a name. Call it numbers. Just whatever, call it something. Doesn't really matter. 78, 90, 456, 673, 111, 381, and 21. Okay, I'm going to do one variable stats on that number. So I'm going to go to calculator page, menu, 6, 1, 1. And you're going to choose numbers. And you get mean 258.57. You get a standard deviation for the population is 228.335. And to get the variance, you've got to square this term. So you've got to square that. Let's see if I can do that. So there's kind of a cool way of doing this. I think it's stored in there. I'm just taking a guess. Let's see if we can find the population standard deviation. No, that's not it. Be right next to SX. I think I saw it. Maybe it's QX? No, oh well. Let's just type it then. So it'll be 228.335 squared. So it would be, variance would be 52136.9 approximately. So Beethoven's symphonies are, so let's kind of just draw this, sketch it out. So in the middle is 37. Add 12, so that's 49. Add 12, that's 61. Add 12, that's 73. That's the middle. Go backwards, subtract 12, that would be 25. Subtract 12, that's 13. Subtract 12, that's 1. So I've got this labeled. So it says, determine the whole number of standard deviation values that would include the following data values. So 61 would be right about there, just kind of plotting it. 35 would be here-ish. 15 would be right about here. And 26 would be right about here-ish. Okay, determine the whole number of standard deviations. So if we go 2 standard deviations to each side, I think we'd be okay. We're right on the border there, so I think 2 standard deviations. An outlier is at least 2.5 standard deviations away from the norm is a symphony that is 6.4 minutes an outlier. So let's see, standard deviation is 12, so 2.5 times 12. 2.5 times 12. Let's figure out what that is. I don't know, to multiply it. So 2.5 times 12. So we get 30. So away from the norm is a symphony of 64 minutes an outlier. So 64 is right in there. That looks unusual. Has to be 30 units away from the norm, away from typically. Okay, so we're going to say that for the, I guess for the median. So if we use a mean of 37 plus 30 is 67. So 67 is kind of the unofficial number there. 64 is within 67, so I don't think, so I would say no, it's not an outlier. So how I did that is I took the middle or the norm, which is 37, and I added 30, which is 2.5 times the standard deviation to get 67. That would be an outlier, or anything past that would be an outlier. Supermarket wants to find the percent of shoppers who use coupons. A manager interviews every shopper during the greeting card aisle. That would be convenience, right? Just kind of lazy. Whoever's close by. Internet poll, self-selected. Do you prefer reading exciting historical novels or dull autobiographies? I think the wording is leading. So maybe leading, wording, a loaded question. Sometimes we just call this a loaded question. It's definitely loaded. Loaded question. Just the word choices. I mean, we could have used different words in reading and exciting and dull. Those are really not good terms. They're not neutral. Use non-neutral language. Sketch a normal curve and then answer the question. So let's try to go in the middle. It's 10. No, sorry. Middle is 45. Go 10 to the right, that's 55. 65 and 75. And this is 35 and 25 and 15. Find the percent of data with the interval from 35 to 65. So I know this is 34 and this is 34 because it adds up to 68. I remember this is 13.5 and this is 13.5 because those four add up to 95. So 95 minus 68 divided by 2 is 13.5. So I'm really adding up from 35 to 65. 34 plus 34 plus 13.5. So 68 plus 13.5 is 81.5. Find the percent of data greater than 65. So 65 and bigger, like this way is shaded. So I know this one is 2.35 and this is 0.15. So I think that'd be 2.5. And answer that question, but it's just because I remembered it from, but you can always figure it out using the empirical rule. Class of 25 students, one student receives a score of 100. These grades are normally distributed normally, which mean of 78, a standard deviation of 5. Do you think the student score is an outlier? So 78. 5 more would be, that's the middle. 83, 88, 93. So 93 is 3 standard deviations away. In each direction, like a total, like that's 99.7% of the data. So this is outside of that. 100 is somewhere over here. That's extremely, so yes, more than 3 standard deviations away from the mean, or from the mean in this case. So yeah, that's it.